All right, we're live. Yeah, so super excited to have you guys for another Moonbuilders workshop. We're in the fourth edition this time, and today we have Nader from the Graph. Super excited to have you guys here. So basically, the Graph, if you're not familiar with it, it's an indexing protocol that organizes the blockchain and makes it easier to get data from the blockchain, and it's accessible via GraphQL, right? So I really like this analogy that I think one from your team, Nader, gave in a podcast. It's like so Google indexes the data from the World Wide Web, right? And the graph sort of like indexes the data from the blockchain. And what happens is that data is available on chain, and we hear about all these great stuff about blockchain that where data is immutable and available in a decentralized fashion, but it's not really accessible sometimes. And when you want to ask like harder questions from the data that is available on the blockchain, it's not possible, right? So basically, this is because data is stored on events. And what the graph allows you to do is to access the events data and organize it in a way that it's accessible and available to answer these kind of hard questions that are not really straightforward to answer, right? So yeah, with that introduction, take it away, Nader, and thanks for joining.
Yeah, absolutely. Thank you for the introduction, and it's really cool to be here, and I'm excited to be talking about all of the things that we're doing over at the Graph and kind of teach you hopefully how to build your own subgraph. And by the end of this workshop, you're going to have a code base to work with. You're going to have a little workshop documentation to kind of work with. So if you are interested in taking this and running with it and coming up with something cool on your own, that would be great to see. So with that being said, yeah, let's go ahead and get started. So maybe I'll go ahead and share my screen. All right. Can you see my screen okay? All right. So yeah, so I'm going to do kind of a couple of things. First, we're going to do a quick slide intro to kind of walk through a little bit more details about the graph. And then we're going to do a live coding demo where we're going to basically clone an existing project to kind of initialize all of the pieces that we need to deploy a subgraph. And then we're going to deploy the subgraph and we're going to test it out. So with that being said, I'll go ahead and introduce myself again. My name is Nader. I'm a developer relations engineer at Edge and Node. And as a developer relations engineer, I get to do all kinds of stuff. It's kind of like a combination of a developer as well as an author and writer and a speaker as well. So I'm currently working on a couple of internal projects where we're building out full stack dApps. I'm also working on the initial beginnings of maybe doing some libraries and open source stuff as well. But I'm also doing a lot of writing. So I've written a couple of posts on getting into just the whole Web3 ecosystem, also building out full stack dApps and what that kind of modern stack looks like. And also, of course, working with the graph. So what is the graph? Well, he gave you a pretty good introduction, but essentially, yeah, it's kind of like an indexing protocol for querying global data or decentralized data. And initially, it was blockchain data. So you could think of Ethereum would be kind of the main, chain that we were interoperating with. But we are continuing to, expand and add additional data sources. So in the future, like it's not only going to be blockchain data, but you could kind of think about all of any public data, any data that is available publicly can essentially be indexed by the protocol. So we're going to look at how that works like in depth in just a moment. But I guess the easiest way to kind of talk about like why the graph exists and why so many people are using it, when you think about blockchain data and how you might build a modern app on top of something like Ethereum, you might consider, like if you're a front-end developer, how you've queried data from Ethereum in the past. Now, if you want to get just a single piece of state, if you just want to kind of like make a single query, it's actually fairly easy. You use something like Ethers, or you use something like Web3.js, and you just make a call to the chain, to the contract that you want to interact with, and you get your data. But let's say that you wanted to have anything past a single basic operation. So let's say you want to aggregate some data, or you want to query and get multiple pieces of data. Let's say you maybe want to get a list of transactions of things that have happened over the course of, I don't know, the last couple of months, and you want to maybe pass some arguments in, and you start, building out more of a complex selection set that you typically would probably need to interact with the database to get. Well, that's not really available for blockchain data. So in the past, what a lot of teams and companies and developers were doing is they were building out these centralized indexing servers. So you would basically spin up like an EC2 instance on AWS. You would build out your logic to kind of index and query all the different transactions that happen in the blockchain or in the smart contract that you're wanting to interact with. And then you would save that data in something like Postgres or maybe DynamoDB, build an API on top of it, blah, blah, blah. You're basically building out your own API layer on top of the data that's there. And then you might have like a listener or an events subscription where you're listening for new transactions and you're kind of continuing to update your server. Now, there are a couple of problems with this approach. Well, first of all, if you believe in decentralization, this kind of goes against the whole idea of decentralization, because you no longer have a decentralized data layer, you now have a centralized data layer. And if this database goes down for whatever reason, then your app is going to go down. But also, if anyone, for any reason, went in and changed something, then the source of truth is not going to be matching what is on chain. The other problem with this approach is that it actually takes a lot of engineering resources to build one of these. So if you have an idea for a dApp and you want to kind of like get data from here and here and here, you're going to have to build out a new indexing server for that data. So it's kind of like resource intensive, and it breaks the idea of decentralization. And that's kind of where the graph comes into play. The graph is kind of like, I would say, almost like a core piece of architecture when you are building any type of modern app, or you're going to need something like the graph, right? When you're building out any type of modern app where you need these rich queries, you need these rich selection sets. And the graph allows you to basically, as a developer, define the different smart contracts that you want to index and write a fairly concise API around all the data that you want, deploy it to a decentralized network, and you're given an open API that you can then use in your application. And, it's kind of like, if you think about a modern application like a web app or a mobile app, how performant and how good of a user experience that you're used to seeing these days, that's kind of the experience that you often want to give. And that's kind of what the graph allows you to do. You can create, like I mentioned, all these different APIs on top of all of the different data that is stored in these smart contracts. But also it opens up a really nice API layer, which is GraphQL. And that's kind of the querying language that the graph uses. And that's kind of where the name comes from. Now, there are tons of projects using the graph these days. So a lot of them are in DeFi, they're in gaming, they're in finance, and pretty much anything that you could think of that is a dApp. So companies like, or I would say projects like Uniswap are using the graph in production, Foundation, a bunch of different types of a bunch of different applications that you probably use or heard of, Synthetix. So, not only is it something that like is out there that is being used, but a lot of people are using it and it's working and being used in production these days. Now, this is kind of like an idea of what a graph looks like if you've deployed it to the hosted service. So once you've deployed a subgraph, you can go in and actually run queries on it from the Explorer. And then here you kind of have a good idea of all the different pieces that you might need to integrate into your front end. So we have the API endpoint, but also you have the Explorer on the right-hand side. You'll see some documentation. So you can basically see all the different queries and all the different fields that are available for the different types that you'd be querying from. And we're going to kind of look at how this actually works, building this out from scratch. So how does the actual decentralized service and the decentralized network work itself? Well, when the graph was initially built and it was kind of like, the idea was there and they wanted to kind of launch it, it was initially launched as a hosted service. And the hosted service was launched, I believe, in 2019. And since then, the decentralized network has been launched at the end of last year, at the end of 2020, which is kind of like the decentralized version of the hosted service. So right now, there's kind of like two ways to deploy a subgraph. You can deploy it to the hosted service, which is a kind of like a centralized service. And what we've been rolling out since December 2020 is the decentralized network. And to run the network, there are a bunch of different participants. So you have indexers, you have curators, you have subgraph developers, and you have delegators. All of these different people are incentivized to kind of like be participants in the decentralized network. And the way that they participate is with graph tokens. So with graph tokens, you can stake into an indexer, you can stake and you can signal towards a subgraph if you believe a subgraph is a good API. And all these different ways to participate, and therefore you can kind of make money, and also just be a participant in a bunch of different ways. So if you want to learn more about actually being a participant and using your GRT to be a participant, I would definitely check out our documentation and kind of learn a little bit more about how all that stuff works. Now let's now.
I have sorry, Nader. So I have a question regarding that, right? So as a consumer, for example, if I want to consume data, do I need any GRTs, or is GRT, the graph token, really involved in sort of when you're going to consume data, or?
Yes. So as of now, if you've deployed an API to the hosted service, it is actually completely open and it's free to query. In the decentralized network, once you've deployed a subgraph or someone's deployed a subgraph and you want to start querying against that graph that is on the decentralized network, there will be a fee. And I would say, like, if you've ever used something like, I guess, AWS API Gateway or AWS AppSync or even AWS Lambda, you have like these charges that are maybe like 1/1000th of a cent or 1/100th of a cent or whatever, like per invocation. It's something like that. The pricing is actually in the range. It was just released actually not too long ago, but I believe it's in the range of like 0.0025 cents or something like that per query. And the way that you would set that up is you would stake or put up some GRT that would basically be, part of how you would fund that.
So you'll have like a credit, and it'll be deducted from that
right.
credit. It's sort of like what you mentioned with AWS and so on.
Exactly. Yeah.
Right. Thanks.
Now, to actually build out a subgraph, we have a lot of tooling and things like that, and we're going to kind of look at how all that works. But using the graph CLI, you can initialize a new subgraph using the init command. So you would say graph init, and then it would kind of walk you through a few different steps, asking things like the smart contract address, and maybe the start block, and maybe the network that you want to deploy to. So again, we kind of support a bunch of different networks, including Ethereum mainnet and all of the different test nets, as well as Moonbase. So you initialize your subgraph, you define the data sources, you then define your entities, and the entities are basically the pieces of data that you would like to query for. So the way that we do that is we define these entities in GraphQL schema definition language, GraphQL SDL. And then we have our own also directives that kind of allow us to kind of map the different types and fields into an indexer node and save that and make it available for querying. And that's something else that we'll look at. And then finally, we have the assembly script mappings. And the assembly script mappings are essentially kind of the business logic of your subgraph. So when the graph is deployed and you've defined all of the different events that you would like to index, or all the different functions that you would like to index, you basically are going to be triggering one of these functions every time the block that for the contract that you've defined has been indexed. And anytime any of that data is there, then you need to kind of like write the logic for how that data is stored. And essentially, you're kind of just creating a copy of the model that you've defined in your GraphQL schema. So a very basic example of that might be like you've defined a user entity in GraphQL, and then in the event, you have the user ID, the user's avatar, and maybe the user's address or something like that. And that would be 3 different fields, and you would just basically create a property on the user for like user ID, user address, and user avatar, and then you would just save it. So, but I think a lot of that will be a lot clearer once we kind of like walk through some code. And then you can deploy. So let's go ahead and take a look at this workshop. The workshop is located in my GitHub. So it's github.com, of course, /dabbit3/Moonbase Moonlotto workshop. I wonder if I can, you want me to share this maybe? This link, or can you share it maybe? So
yeah, sure thing. I'll share it.
So there's a couple of like great resources if you want to get started with the graph and Moonbeam and Moonbase. So basically, the Moonbeam docs have a pretty good introduction. There's also, let's see here, the Moonlotto subgraph, which is kind of what we're going to be working with. And then there's the workshop that I'm using. So kind of using these three resources, you should be able to go back after this workshop and really get up and running pretty easily. But what we basically want to do is we want to take this subgraph here and kind of deploy it and then test it out. And after that, we're going to look at a UI that was built by, I believe, Alberto and the Moonbeam and Moonbase team. So to kind of see like a front end that's on top of that. And then we're going to query for the data as well in the graph console. All right, so to get started, let's go ahead and maybe clone the repo and just walk through some of the code and then kind of go from there. So if you kind of want to go back and walk through all the steps there, you can kind of see, there's a little bit more description about what's going on. But the basic thing that I want to do is I want to go ahead and get started by cloning this repo. And here I am in like a completely empty Git repo. So I'll go ahead and open this up in my text editor. And this is a basic, really basic example of a subgraph. And pretty much all subgraphs are going to have very similar architectures and file structures. And the main files that you'll be working with are the schema.graphql, the subgraph.yaml, and the src/mappings, which we'll look at in just a moment. But the core idea that you can kind of like say when you look at any subgraph, if you want to get a good idea of what's going on, you'll probably go into the subgraph.yaml. This is essentially something like infrastructure as code. If you've ever worked with something like AWS, or if you ever worked with YAML in general, it's kind of like configuration or configuration as code. You can kind of think of it. And here we're going to kind of walk through all of the different properties. So the main areas that you first might look is the schema. And this schema is the GraphQL schema, and this defines the data model. So what are the pieces of data that we're going to be interested in saving and querying for? So for this workshop, we're working with a lottery system where you basically can be a participant, and it's going to randomly choose a winner, and that winner will receive money. So for the schema that we have here, we have a few different main types. We have a round, we have a player, and we have a ticket. Now, if you've ever worked with GraphQL, you've probably used to maybe a schema that looks something like this. So this is just plain old GraphQL, and then we have a few different directives that are specific to, I would say, the graph. One of them is entity. So using the @entity directive, we're able to basically say, hey, this is something that we want to be stored and saved and available to be queried from the indexer. And then the second thing that we have is the @derived_from directive. And this allows us to define relationships. So imagine like a one-to-many relationship. In this case, it would be rounds, tickets, and so on and so forth, or a many-to-one relationship. So in this case, we're basically able to define the fields that we'd like for a round. So we have our index, the prize, timestamp, etc. And then we'll be able to then send a query to this API and say, we want to get all of the rounds, and this will return something like an array. And then in the array, we'll have the fields for each item in that array. And then we'll be able to also, though, get a relationship between the rounds and the tickets. So we might want to say, we want to get a query, and we want to get all the rounds and all the tickets for that round. Or we might want to get a player and all of the tickets for that player. Using this @derived_from directive, we're automatically able to map that one-to-many relationship between different entity types, which is pretty nice. All right, so we have like the three main fields here, or the three main types, I'm sorry. And this gives you a really good idea like around the type of data that we're expecting to receive. So we're going to be able to query for tickets. we're going to be able to query for players, and we're going to be able to query for rounds. So once we've defined our schema, we can now continue on with the rest of our subgraph, because everything else from here kind of depends on the schema and how the schema is defined. The other thing that we might want to take a look at is the source field. In the source field, we have the main data for the data source itself. And here we kind of have our data sources key. And for a subgraph, you can actually have multiple data sources. So you might have multiple contracts that you want to query from, and therefore you can kind of build out pretty interesting stuff. But in this case, we only have a single data source. And here we're basically saying we want the smart contract address to be listed here. We have the ABI definition, and we also have the start block. And if we don't use the start block, we will basically be querying, or we'll basically be indexing everything on the entire chain. So using the start block allows the indexer to be a lot more performant, because we can just start from when the contract was deployed and then go forward from there. The next thing we might want to define is the entities. And this is pretty simple, because we've already kind of said in our schema we have a round, a player, and a ticket. So this is going to match that directly. So the entities that we want to index are the player, the round, and the ticket. And this is going to always match your GraphQL schema. And then really the last thing we might want to look at are the event handlers. So anytime the player joined or the lottery result events are emitted from the smart contract, we can now take those events and map them into a local function. And then in that function, we can define what we would like to do with that data and how we would like to save that data. So we're basically saying, okay, when this player joined event is called, we're going to be getting these arguments, and we want to map all of that data into this function here called handle player joined. And then the same with lottery result, we want to say handle lottery result. Now, all we need to now do is say, okay, where are these functions defined? And those functions are defined in this mapping template. So we have src/mapping, so we can go there. And here is where all the logic is going to be for our subgraph. So before we do that, though, we can actually go ahead and do some code generation. So the GraphQL schema that we've defined here has these different types, and we're actually able to create some TypeScript types, as well as TypeScript functions and code that we can basically use as utilities in our subgraph. And the way that we can do that is we can just run the graph code gen. And in this project, we have a shortcut for yarn code gen, which basically is calling graph code gen. And then also we're defining the output directory. So the yarn code gen is essentially calling graph code gen. And then we're saying where we want these types to be created. So we're basically generating some code based on that GraphQL schema, and we want to drop those in the src/types directory. And then that way in the src/mappings, we can now import from the types. So let's go ahead and do that. So I can say yarn code gen. Okay, looks like we have an error. So let's see what's going on here. I think I may have, I think I need to install the
yeah, you have to install the dependencies first.
Yeah.
Right? So that's just while this is installed, let's roll back a little bit, right? So the problem is that in the lottery contract, it emits some events, and that's the way that the contract is using to have some data available, right? It's storing some data on chain, let's say it like that. So right. the thing is that what you showed us right now, so you have the schema file, and the schema is the type of data that I want to organize or get organized, let's say in a way, in a nifty way that I will then query. And then the mapping is going to handle, basically, I received an event, and I'm going to call the function, and that function is going to organize the data in a way that I can retrieve later on, right? So these are the three main steps that you need to understand at a high level when you're going to deploy a subgraph.
Yeah, absolutely. And I think a really interesting thing is often when you're looking at the events, is that the events will often map fairly well to your types. So like here we have, this is the actual smart contract itself where we have like a player joined. So this could also, this could be very closely mapped to maybe a player because the player joined is going to have all of the information about the player, right? And maybe, of course, it's not going to be exact, but it's a really, fairly easy way to kind of get an idea around maybe where you might get started. So you would look at the events, you see the data that's available here, and then you can basically, map that essentially a lot of times directly to a type.
Exactly. All right, cool.
All right, so after we've installed our dependencies, we'll try that again. So we'll say cogen. And then if we go into our SRC folder, we now see that we have our types there. So if we can go here, that we have a bunch of code that was generated for us. So we have a schema, and here you should be able to see that we have 3 classes that map directly to our entities, as well as some other TypeScript code that we can use, helper functions and stuff like that. So we close that, and the mappings, and this is kind of where all of the code is typically going to be. And here we kind of just go through, and it looks like we have about 70 lines of code, including comments and stuff. So maybe this is going to be, you could probably think maybe something like 50 lines of code or something for this subgraph. And the idea is that we have in our subgraph, we have these 2 event handlers calling these 2 functions. And then in these mappings, we just define these 2 functions. And the general idea here is that we're going to be getting some data passed in the event. And in our case, that event is going to hold these 4 or 5 different types here. We have an integer address, integer, Boolean, integer. And then in that event, we can do whatever we would like for it. But at the end of the day, you're going to basically be creating an entity and then saving it. So in this case, we have a round, and we're going to first see if that round already exists. And if it does not, then we go ahead and create it here. And then we add a couple of properties to it, and then we save it. So here we've created a round, and now this is going to be kind of saved in our indexer. And then we continue on. We do the same thing with player, and then we do the same thing with ticket. And I'm kind of glossing over a lot of the details around the syntax and stuff. But if you've never worked with assembly script, it's actually very, very similar to TypeScript or JavaScript even. So it's not really a whole lot to, I would say, get up and running with. And a lot of the logic that happens in these mappings is actually very consistent across multiple subgraphs. So like you might just look at a couple of example projects that are out there like this one and kind of get a good idea around like what's going on. So with that being said, we have a couple of other, again, entities that are being saved. We're saving the round, we're saving the player, we're saving the ticket. And then we have essentially the same thing going on here with the lottery result, where we're kind of like, creating different fields on this different entity, and then we're saving it. All right, so
another question, Nader. So what's the difference between, for example, the ticket save on the line 47 and the ticket save on line 68, right? So I mean, they're both doing the same command, but why calling it on line 50, like on one function, and why calling it on the other one, right?
Yeah, these are going to be handling different types of events. So like this event is, let's see here, when the player joined, and then when the lottery result is completed, I guess. So the player join is going to have different data coming in, and it's going to be for a different use case, I would say. And then for the lottery result, it's going to be for something different. Let's see here if we can go through this and see real quick.
So I think they basically are like saving different kinds of information inside the same kind of like ticket information. Let's say,
it looks like the ticket is created like here in this function here. So we're creating the ticket when the player joined, and then here we're updating the ticket where we're kind of saying the ticket dot. This is basically the person that wins the lottery, I guess. And then we're going to say that this person is the winner, and then we're resaving it. So like, I guess when we're initializing it, let's see if we have is winner on there. So we're setting is winner as false, and then this is them winning, I guess. And then here we're just saying that their is winner value is true. So setting it, changing the flag from false to true.
Yeah, exactly. So in line 65, you're loading the ticket ID, right?
Oh, right.
And then you're just updating the value to say, okay, this ticket is the winner, and that way you need to save it again to like update that entry. So you can even like modify instances of things that you have done in the past, right?
Yeah, essentially, and you could kind of think of like ticket in this case as being like an object or a map where we have like different fields, and we're just like modifying a single field here, and then we're just saving it.
Exactly. Cool.
All right. So yeah, are there any questions before we kind of continue on? And I think I may have to just like quickly just move into a different area. I'm getting, believe it or not, moved.
It happens. It happens.
Yeah.
Yeah, we're now in the work from a remote place now, so this is normal.
Yeah, I'm in. So basically, you know, I'm in Miami working with my team here for a couple of events. So not in my typical studio. So I appreciate everyone understanding and all that. So anyway, so what we want to do now, so we have our subgraph, everything ready to go. Like, so we're ready to maybe start actually deploying this thing. So the way that we're going to do that is we're going to go ahead and go to the graph. And here I can go ahead and go to my dashboard. And what I want to do is I want to go ahead and create a new subgraph. And to do that, I'll click here, add subgraph. And I will call this Moonbeam Moonlotto. Give this a subtitle. And we'll go ahead and we can either make this public or private. I'm just going to go ahead and hide this for now because I already have a couple of them. Well, I guess I can make this public. That way if someone wants to go in and find it later, it'll be there. And then I'll click create subgraph. And then this gives us the UI for us to now go ahead and deploy to. And what we're going to now need is the name, our username / the subgraph name. So for me, that's dabbit3 / Moonbeam Moonlotto. And we can now go ahead and deploy this. So the way that I'm going to do that is I'm going to go back to my code here and I might just go ahead and I'm not sure what else. Oh yeah, change that. Go ahead and close out some of this stuff here. And what we have in our scripts, we have a few different scripts that are kind of like written out for us. But the one that we're interested in is this deploy script. And here you can see that we're calling npx graph deploy. We're passing in a few different flags. One of them is the actual location of our subgraph in our UI. So in our case, that's going to be dabbit3 / Moonbeam Moonlotto. And with that being said, that's kind of the only thing we need to switch out. And we can go ahead and save that and go back to the CLI. And from the root of our project, we should be able to say yarn deploy. And then this is going to go ahead and deploy everything and hopefully start indexing it. And I would say fairly shortly, within a couple of seconds, we should be able to go ahead and start querying data.
So this subgraph is being uploaded to the IPFS. So that's nice because it's a decentralized kind of like storage solution. But then this is like the gateway so that the graph can actually like serve the data that you're going to ask to, right? So this will provide the API that we want for in this case, a Moonloader example. So
exactly, yeah. And then in the UI itself, it's going to provide us with like a graphical, is what they call a graphical explorer. Mm-hmm. And here, so yeah, it should be now a successful deployment. So we get the green check mark, we get the location and all that. So, and it also gives us our endpoints. So if we wanted to kind of build out a front end on top of this, we could use a GraphQL client like Apollo or Urkel or any of those, any of the ones that are out there. And then we also have subscriptions, which allow you to have real-time updates. So let's say someone wrote a new item to the graph or to your smart contract. Once the graph indexes that, then you can subscribe to those updates and get the real-time updates. So you don't have to like poll your server or do any like those types of things. All right, so if we refresh, we now see that we have 801 entities. This means that there are 801 items that have been stored. And that means that everything seems to be looking good. And it's already synced 100% of all of the items that are in our smart contract. Because if it was not, it would say syncing and it would kind of give you like a percentage of like how much was done. And I think I just refreshed and broke something. There we go. Okay. All right, so that's great. So one of the cool things about, I think, GraphQL is like this idea of a graphical explorer and how self-documenting it is. And this is not really something I would say unique to the graph. This is just kind of how GraphQL works. We have a graphical editor where you can go ahead and start testing out queries. So here we can go ahead and define a query here on the left-hand side and run the query and get our data that's returned here. But what's really nice is you can do something called schema introspection, meaning we can go into our schema and we can see all of the different data and essentially kind of have like an idea around the API around how we might query for this data. So in this case, we see that we have a round, a player, and a ticket. And if we're unsure of the different fields that are available, we can just click here. We can see that we have, an ID is a type ID. We have an index, we have a price, and we even have the relationships. So here we can say, we want to query not only for the rounds, but we might also want to have the tickets. And then for a ticket, we can actually see is gifted, is winner, and you can even see the player. So here we're kind of getting these rich, deeply nested queries that are all available for us here. So all of the different querying capabilities are all there as far as different data access patterns that we might want. And another interesting thing is that we can pass in these different filtering arguments. So we can just query directly, or we might want to say something like, we want to order by like ID. And then we might want to do order direction, like descending. We also might want to say skip. And then we're going to start, after a certain number. So yeah, I think that's it. Yeah, do you have any questions as far as like any of the stuff we just went over?
No, I think let's just like roll back a little bit, right? Because there is a lot of information to digest here. So basically, what's going on is that we have a Moon Lottery contract that it will just like players can join, right? And when players join, it emits an event saying, "Hey, this player has joined." When there's enough players, there will be actually there will be a winner that is drawn more or less pseudo randomly from the lottery, and this emits another event, right? So what you're doing here right now is it's just asking the hard questions, right? I mean, that's the thing. That's basically what the graph brings to the table. Is that I might just ask, hey, from events specifically, hey, did a player join? And that's an easy question that I can ask directly to the Moonbase Alpha testnet, right? But in this case, you can actually ask, hey, give me information about the lottery round 5, and it's going to tell you, hey, depending on how you query, right? The lottery round 5, you have this many tickets, this many players, this guy was the winner, and this basically a way to ask all these kind of hard questions or hard information that the data is there in the blockchain, but it's just not easy to ask, right? So.
Yeah, basically, and it's gonna, when you define your address in your subgraph here, it's just gonna go into this smart contracts address, and it's gonna kind of like find all the different transactions. It's gonna just map over all the different transactions, look for those events. It's gonna go in, call these functions, and that's kind of the way you would think about it. So if there's only like 5 transactions, then this would be a quick deployment, right? Let's say there's 1 million, then it's going to take a little longer. So it just kind of depends on how many transactions are there. That's going to be kind of the data that's available. And I think what's interesting is that you're seeing people start building out their smart contracts almost with a specific, I would say, target of the graph. Instead of a lot of times, I would say like in the past where developers would write their data directly to something like Ethereum or to the blockchain itself. Because they're able to get this data out of the event itself, it's a lot less expensive and a lot faster often to not save the data at all. Instead, just submit the events, and then that the graph is going to index those for you, so you don't actually have to save those on chain. So I thought that was pretty interesting stuff.
Exactly. Like when I was reading about all this, I was like, hey, actually people are using events to store, because it's not really storing, right? It's just there. I mean, like it's storing data on chain in a cheap way. Right, it's exactly right what you said, right? I mean, storing actual data on the blockchain is super expensive, like crazily expensive. You can go to Google and just like Google it, and I think it's like tens of thousands of dollars per kilobyte, or it's just crazy the number that you get. Mm-hmm. In this way, you can actually get data, like fetch data from the blockchain, so that you're able to store it via events, and then rely on services just such as the graph to get that data for you and serve it to your DApp or something, right? And this is something that a lot of people don't really like. I mean, I didn't even really understood it until like, I heard some podcasts and stuff. Like a lot of these projects like Uniswap or Balancer, they rely on the graph to serve data for the front end, so they can show like really cool plots and really nice information to their users about pools and so on, right? And that's super powerful for sure.
Something else I guess I'll show is that this is the app. I think this is the UI that you built.
Yeah, it's it was a couple on the team, but yeah, we built it. So you can actually refresh it, because there's a round that it's almost there.
Okay, cool. So this UI was built on top of the graph. So that's pretty cool. This is just like, taking the data from the query and like formatting it nicely and kind of giving you a better UI of what's coming back, right? Because like when we make this query over here, we see that we have like the index, the address, and the price. You can kind of get that information from here, but this way you kind of see it all formatted a lot nicer. So sometimes it is a lot cooler to see this in action somewhere than just like reading it from an API Explorer, right? So I thought this is pretty cool.
Exactly. I mean, you can actually, do you have tokens to participate?
I do not have any, no.
All right, I'm going to participate so we can see basically so there are actually basically 9 tickets already there. And when there are 10 tickets, there's going to be a winner that it's going to be drawn, right? And what's going to happen is that the graph is going to actually fetch that event, and it's going to basically say to the subgraph, I mean, the website is going to fetch via the subgraph the new round, and it's going to display the address of the winner at the bottom part of it, right? So basically, I'm actually submitting a transaction right now, and this is actually a question that I had is how long does it take for the graph to like the whole loop, right? Of like fetching the event and have that data available for a subgraph to query.
So it should be immediate. When I say immediate, as soon as the data is written to the chain, it should be emitted. It should be emitted, and the graph should pick it up and make it available immediately. Now, if you have subscriptions enabled, which is kind of like what we saw here, where we're given that subscriptions endpoint, you can actually subscribe to the updates directly from your client application, and then you have these real-time events coming in like immediately, and you can of course handle those like on the client.
All right, gotcha. And you can see now that there was a round 38. It was already drawn, and the winner was selected. I don't know who that address is, so yeah, good luck. Congratulations to the winner. And that's actually pretty fast. Like I heard the MetaMask confirmation, and it was just like like a few seconds afterwards, it's just like displayed at the front end, right? So this is really cool. And we have now another round that started, and we have, another person already participating. So yeah,
I saw that. It went from 9 to 10, and now we're back to 0. I mean, back to 1.
Yeah, exactly. So it's just like a fun thing for the community to actually see a DApp using the graph, right? I thought that was cool to have.
So one interesting thing, so it looks like we have the timestamp in it. Yeah, I like to often, pretty much add like a timestamp to pretty much everything, because it just offers like, that additional like metadata that is really nice to have, that of course you probably wouldn't I would say index, I would say you probably wouldn't say that on chain yourself, right? But like it's pretty, I mean, it would be there, I guess, since the transaction timestamp would also be there, but it's pretty cool to just be able to like look inside the, the transaction and get any additional metadata, and then just add that to your entity. So like pretty much all of the different subgraphs that I build always definitely add like a created at timestamp, and that also gives you additional querying capabilities, because then you can start filtering and sorting by the dates, and getting pagination going and stuff like that pretty easily.
Yeah, definitely. So I mean, I would say this is all available code, as Nader showed. I mean, you guys, if you're gonna want to get started with the graph, you can just follow the links, and you can even modify this DApp yourself. And if you want to play around and add, like the timestamp, like you mentioned, just play around and have fun with it. And I think it's a good starting point if you want to get started on the graph, for sure.
It'd be really cool if you took the link to this, or you maybe merge that code base in with the subgraph here, maybe. Or
well, actually, we got you covered. If you go to the bottom part of the Moon logo, like the website, at the bottom you have the code. I mean, it's not in the
nice.
same.
Okay.
It's not in the. That's actually to my repo, but I want to put it on the official kind of like repo. Yeah. The code is there, and people can use it. Just for fun. Don't judge the code, because I'm not an expert coder. We just built it to have fun and have this available for people, right? So, but yeah, definitely, they can start playing around with this and modify it as they seem fit, and just add and have fun with it, for sure.
No, it's great. I think it's a good way to kind of put everything together when people like to see the actual code base as well. So I think between this code base, the Moonbeam docs that you already have there, as well as like maybe this subgraph, and then maybe my workshop info, like you have everything that you need to get started, I think, building.
Totally. And when we were doing the docs, it was kind of like I felt there was something else we needed, right? Because like when you're building subgraph, unless you see the end result, you really get to see like the magic of what it's doing on the back, right? So that's why we were like, oh, let's just like for fun, let's just do this DApp, and just to see the actual end result, right? Like the query and the data displayed in the front end where you can actually see it. So, all right. So I do have some questions now that we have some time, right? So, do you have a sense of how many queries are done via subgraphs, on a daily basis, from these clients?
So I think the last metric that I was made aware of or given, I believe, was at the beginning of last month, and it was something like over 20 billion queries per month. So I don't know how many that is today, but like almost a billion per day, it sounds like we're at.
Yeah, it's crazy, right? I mean, the amount of data that is being fetched, it's just crazy. And we're at a point that blockchain technologies just keeps growing, right? So I mean, we're still a long way to go to. We're still totally growing, probably. So I don't know how long.
I think we'll be at trillions. I think like trillions will be. I mean, I would say based on this graph, based on the growth, it wouldn't be hard to say. It wouldn't be like that far out there to say we'll be at possibly a trillion or something like that, right? At some point soon, because when you think about applications and modern UIs and stuff like that, you're often like hitting your back end, like a lot of times, right? So like that wouldn't surprise me at all. And then also, if you think about all of the volatility and things that were happening with last month, maybe I'm thinking a lot of these DeFi apps probably ended up seeing increased usage and stuff. So yeah,
definitely. And another question that I had, and I understand subgraphs, but what are the core benefits of subgraphs, right? Because I feel that they provide some flexibility, right? but they're also provide another layer of complexity, right? So it's kind of like there's a benefit to it. You can actually go, there's an X at the top. There you go.
Oh, there we go. Sorry.
There's no worries. There's actually like a benefit to it because, you know, you have data is malleable with it, right? You can program whatever you want, but it also adds a layer of complexity. So what are the core benefits of subgraphs, you think?
So I think in addition to kind of like all of the benefits that having like this aggregated layer that allows you to kind of just essentially have additional data access patterns. So you can't really hit a smart contract with multiple queries at a time and have it be performant. So you can maybe hit the smart contract and ask for one thing, but you can't say, okay, I want to get this smart contract. I want to get like a list of data from like this time to this time and all this other stuff. Like so first of all, it's a lot more performant because you have all of that data like available, like indexed for you. But I think one of the really, really powerful things that people start to realize when they start using it is that it's just giving you all of the benefits that GraphQL gives you. So there's a reason that like Facebook and Amazon and Airbnb and Uber and like literally every Fortune 500 company out there is quickly moving and building production apps on top of GraphQL API gateways. It's because like GraphQL has all of these additional features that REST just doesn't have. So for instance, there's the idea of overfetching and underfetching. So when you build out a REST API a lot of times and you need to get some type of like selection set, let's say for a user, you often will hit like this REST endpoint, and the REST endpoint is going to return a user, and it's going to have their name, their address, their ID, their phone number, blah, 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 all these different pieces of data. But in reality, your user interface might only need their ID, right? So in the past, what you would do, you would get all this data a lot of times, and then you would filter it locally on the client, and then you would render it. But with GraphQL, you actually can just ask for the fields that you want, and therefore you have a lot more performant queries. So for instance, this is extremely important with mobile apps, but as well as applications and users that are in countries that don't have the fast internet that maybe that we're used to in other parts of the world. So it allows you to build out a lot more performant UIs. There's also the idea of not having to build out different APIs for different views. So you just build out this one entity. So like, for instance, a user has all these fields, and then you can now query for that entity on desktop. You can query for it on your mobile. You can query it for an Apple Watch. And you can get all these different selection sets without writing any additional code. You know, subscriptions, which is pretty cool. It's part of the GraphQL specification. Having real-time data like built in is really nice. And
when you mentioned subscriptions, I was like, oh, the Moonlodo interface doesn't use subscription. It's actually pretty crappy because it's just like, you know, like it refreshes every so often, right? So this is something that definitely you can improve like straight away.
Yeah, you can easily modify that, and you know, it makes for a more polished user experience, because like no matter how many times you poll a server, you're never going to get it like exactly right. So having subscriptions, you could say you have 10 updates come in 1 second, and then none come in for the next 30 seconds, and you know that your UI is like up to date.
All right. Cool. Yeah, there's actually a question from Joshua, but actually I'm going to rephrase your question, Joshua, and I'm going to actually merge it with a question that I had as well. So basically his question is, do you need to run the graph on multiple chains such as Moonbeam, Moonriver, or also when it's available on Polkadot? So actually I'm going to merge that question with one that I have is like, how can the graph benefit from a Moonbeam implementation, right? So this multi-chain strategy that we're aiming towards in the future.
So, I mean, you might have a better understanding around like the future of all these different network launches and stuff within the team. So I'm kind of curious, like, what are the different, you know, what is the roadmap? Because I know like recently you have, you know, what we're working with here is Moonbase Alpha. But what else is like coming up in the next
So we have basically
year?
two mainnet launches, right? So we have Moonriver for Kusama and Moonbeam for Polkadot, the Polkadot ecosystem, right? So our idea is to have the graph running on both mainnets. But, you know, the question is sort of, is, you know, the graph must be looking at a multi-chain deployment now, because now we have like BSC, we have Polychain, we have so much solutions out there. So, you know, and now the graph is moving towards like a decentralized kind of service, right? So do you have any opinions of like how the graph will benefit from these like sort of spread out multi-chain solution?
I think the more data that is publicly accessible, the better and the more of a value proposition that something like the graph brings to the table, in my opinion. Because if you think about it, like we looked at the subgraph YAML like configuration, we only defined a single data source. Imagine though you have an application and you want to combine data from a bunch of different smart contracts, data sources, all these different data sources, just like I said. But imagine that you want to build out like some interesting user interface. You can actually combine all of those together. So I would say the more that is out there, the more things that you can build, and the more data that is on chain and stuff like that, the more of a value proposition something like the graph brings to the table, in my opinion. Because again, people are going to start, and they already have started coming up with interesting ways to kind of merge this data and build out different things on top of it. So let's say you wanted to deploy a subgraph that indexes data from here, but also from another, I would say chain. You can actually do that pretty easily.
Yeah, totally. And I feel, you had a comment that really struck me, like projects are now working on building contracts knowing that they'll have the graph running. So I feel that, let's say a project knows that it's going to do like a multi-chain deployment. I wonder if they're going to do something on their contract to, when they emit an event, it actually like prints the chain ID or something like that, right? So then the graph can index the data or sort it by chain ID. So that way, you can query the graph saying, oh, I want to have everything from this chain ID. That's actually pretty cool. I think it's in the future for sure.
Yeah, exactly. These types of ideas and use cases start like popping up in people's heads because there's really so much you can do with it. You're pretty much like completely like unlimited, and you can even like within those mappings. We didn't go into a lot of it, but you can call directly into the smart contract itself as well from within the mapping, or you can call within the graph node itself. So if you already have some data indexed, you can then call it and get it again and use it again. And if you already have data that is indexed somewhere else, maybe or it's not indexed somewhere else, maybe it's stored somewhere else, you can actually call a contract and get that data. So you're basically given an entire API layer to kind of do whatever you would like with there, and then save whatever you would like and make it available for querying.
Definitely. And like, can a graph node, like let's say I'm running a graph node. That, by the way, I think we do have a tutorial on how to run a graph node on Moonbase Alpha. So let's say I run a graph node. Can a graph node point or fetch events from different chains? It can be configured to do so, or it's just tied to a chain?
Absolutely no, it's not tied to a chain at all. In fact, the indexer is completely dependent on the subgraph which has been deployed to it. So it's just going to be like some code that's going to be running that takes that subgraph. It kind of scans the YAML. It goes and it says, okay, this contract, I'm going to go ahead and start running, all of these different functions over this graph and start getting this data. And then it's going to go to the next contract address and so on and so forth. So the indexer node is completely agnostic to any specific chain.
All right, cool. All right, I think that's a wrapper for now. Thanks a lot for joining, Nader. So it's really fun to I think what the graph is building is truly amazing. I think that this is definitely a needed service because there's so much data on chain that it's just not possible to access it without this kind of services. And thanks a lot, guys, for joining. And yeah, take it away if you want to say any remarks.
Oh, no, that was awesome. Thanks for having me. And this is really kind of, I would say, some of the first opportunity that I've had to work with some of this stuff within, Moonbeam and all of that. So I've really enjoyed it. And hopefully I can maybe start building out some more interesting stuff in the future. And I did just drop a link to the workshop there. And if anyone has any questions, the graph, we have a Discord server that's extremely active. I'd be happy to answer any questions as well on social media. I'm DABIT and the number 3 on Twitter. So feel free to reach out if you have any questions.
All right. Thanks a lot for tuning in, guys. And I hope you have a good rest of the week. And yeah, see you around. Bye.